Welcome to Ramanujan School of Studies 0 to Infinity. In this series, we are studying about class 10th physics. The chapter which is running is light, and this is lecture 6. In this chapter, we will discuss about the sign convention and mirror formula. So today agenda is sign convention, mirror formula and magnification. First of all, what do you mean by sign convention? Sign convention means how we take the sign of different and distinct object and its relative position. So, sign convention for reflection by a spherical mirror. While dealing with reflection of light by spherical mirror, we shall follow a set of sign convention called new Cartesian sign system. In this, as we use the sign of x-axis and y-axis in the same manner, here we use same sign convention, that is the new Cartesian sign convention, in solving the question and question related to the mirror formula and magnification. In this convention, the pole E of the mirror is taken as origin. So, pole of the mirror is taken as origin. The principal axis of mirror is taken as x-axis of the coordinate system. So, moving to the next slide, here we have two axes, that is the rectangular axes. So, this is x and x dash, and this is y and y dash. So everything right to the y-axis is positive. So here in this case x is taken as positive. See the direction, and in this here in the left of y-axis x is negative. Upward of the x-axis is taken as positive, and downward of the x-axis is taken as negative. Here right to the y-axis x is positive, and the direction is important. Why? We shall see later here. Now this is the origin. In case of solving mirror formula question based on the mirror formula and magnification, this origin is taken as the pole of mirror. Okay, moving to the next slide. Suppose this is x dash. Here some slightly y-axis move toward the right hand side. So we form a mirror, and this is y dash. Now we have to form a mirror. Suppose this is our concave mirror. So this is the pole, and pole is taken as origin, right? Now our light is incident on the mirror, so this is the incident light. Now everything which is in the direction of the incident light is taken as positive, or opposite to the direction of incident ray is taken as negative. So direction of light is here toward right, so right to the y-axis is taken as positive. So this is positive, and every distance of the left of the pole is taken as negative. So here see in the next slide sign convention, direction of light is this. So in the direction of light, this is positive. Here we have the positive sign, right? Now distance toward the left, that is negative. So distance from the pole here we take is negative. So this is negative. Now height of the object, that is AB, that is the toward the y-axis, positive y-axis is taken as positive, and toward the negative y-axis height is taken as negative. So in the direction of incident right, everything is positive. So this is positive, this is negative. Now what are the different different quantities? That is, first of all we have u naught, that is object distance. So whenever a object is placed in the left of the pole, it is always negative. Okay, so u is the object distance, u naught. V is the image distance, where the image is formed, either it is right to the mirror or the left to the mirror. So sign of the image of distance, sign of the image distance is taken as positive and negative as per the convention of the new Cartesian system. So we have focal distance, we have radius of curvature, and we have magnification. So magnification, sign of magnification also tells about the nature of the image. Okay, so these are the sign convention. Now what do you mean by mirror formula? Mirror formula say that there is a relation between object distance, image distance and focal distance, and this is 1 over u plus 1 over v. This is equal to 1 over f. So 1 over object distance plus 1 over image distance, this is equal to 1 over focal length of the given mirror. The sign of object distance, the sign of image distance and the sign of focal length is as per the Cartesian system. This is elaborated in the next slide by using a numerical. So we have a question here. An object is placed at a distance of 30 cm from a concave mirror of a focal length 20 cm. Where will be the image formed? So here we have to find the distance of image, and the distance of image is measured from where? That is from the origin, and the origin is pole. So we have to make a concave mirror. Suppose this is a concave mirror. Okay, so this is a concave mirror. This is a principal axis and this point is pole. Here in the question, object is placed at a distance of 30 cm from a concave mirror of focal length 20 cm. So focus is here, suppose. So focus is 20 cm. So we have FP, this is 20 cm. We can write here FP is 20 cm. And object distance is 30 cm from the concave mirror. That is, object distance u is at a distance of 30 cm from the pole. So here somewhere this is object, so we can write here this is O, and OP is equal to this is 30 cm. Now FP is equal to 20 cm. So this is 20 cm. Here we can write 20 cm and this is 30 centimeter. Now by using the convention, sign convention, we can write focal length, that is small f, this is equal to, since the focus is the left of the mirror, pole of the mirror, so this is negative as per the sign convention. So we can write here f is equal to minus 20 centimeter, and object distance u is also on the left side of the mirror, so this is minus 30 centimeter. So we can write here minus 30 centimeter. Okay, now we have to find the image. Where will be the image formed? So we have to find the image distance, that is v. V is equal to what? Now as we know that the mirror formula say that 1 over v is equal to 1 over u plus 1 over v. This is equal to 1 over f. So putting all these value with sign of the each physical quantity, that is object distance and focal distance, we can write here 1 over v. This is equal to 1 over f. F is minus 20, so 1 minus 1 over 20. Okay, and minus 1 over u, so u is minus 1 over 30. So this is equal to 1 over 20 with minus sign and plus 1 over 30. So taking LCM, so 1 over v, this is equal to, here we have 1 over minus 1 over 20 plus 1 over 30. So we can write here 1 over 30 minus 1 over 20. Now taking LCM of 30 and 20, so this is 60. So we have 60 divided by 30, so this is 2, 2 multiplied by 1, so this is minus 1, minus this is 60 divided by 60 divided by 20, that is 3, so this is 3. So we have minus 1 over 60. So V is equal to minus 60 centimeter. It means here the image distance is left of the mirror. How? Because this is 9, this is minus sign, so this is, here we have f, and here this is object. F is at a distance of 20 centimeter in the question, and object is at a distance of 30 centimeter, and here f, double of f is r, so this is, if this is 20, so this is r, so this is 40. Okay, now this is r. Now image is beyond the r, that is 60 centimeters, so object is here and image is like here. Suppose this is minus 60. As we know that in case of concave mirror, when object is in between center of curvature and focus, the image is beyond the center of curvature or we can say that image is in between infinity and center of curvature. So image distance is 60 centimeter. This is compatible with our theory, and here minus sign indicates that the image form to the left of the mirror. Now in the nature of mirror we have to find the in the nature of mirror we have to find the magnification. And what do you mean by magnification? It means the image is either larger or of equal size or diminished. So this type of the nature is decided by magnification. So we have the next slide, magnification. So what do you mean by magnification? Magnification is the relative size of image with respect to which one? That is object. It means it may be larger, it may be enlarged, it may be equal to the object, or it may diminished size, or it may be point size. So magnification, basically this is the ratio and it has no unit. It simply say that how large the image with respect to object. So magnification as per the definition is defined as m. M is the term which is related for the magnification, and this is equal to minus V over U. That is minus V. V is the image distance and U is the object distance. Magnification may be for a linear object, or it may be for a two-dimensional object, or it may be for three-dimensional also. So here we talk about the linear object. So magnification is minus V over U. So if we know the distance of V and if we know the distance of U, we can find how large the image is. So this can be illustrated with the above example. So in this question, if someone asks about what is the nature of image, so in previous question one we can say that the image is left hand side as m is equal to as V is equal to minus 60, that is left hand side, that is this is due to negative sign. Now if we have magnification is minus and V is minus 60 and U is how much? U is 20 centimeter. In the previous question U is 30 centimeters. So we can put here minus 30 because U and V are left side of the origin, that is the pole. So magnification is minus 2. It means the object, the image of object is 2 times larger than the object, and negative sign say that it is inverted. Means suppose object is like this, so image is like 2 times but in inverted position. So this is the situation of the magnification or of the image. So in effect, if we know the magnification and the image sign of image, that is plus or minus sign of the image distance, so we can say that the nature of object. So the image so formed is 2 times larger but inverted and real. Okay, because here we have magnification is equal to minus 2 centimeter, and as per the theory of the relative position of image of concave mirror, it is real. Now if someone asks about the magnification by the plane mirror, what do you mean by the magnification? What is the magnification of the image formed by plane mirror? So simply when we had already discussed the image formed by plane mirror is same in size but virtual. It means that it is virtual, so the image formed to the right side of the pole, that is the right side of the mirror. But in this case of plane mirror, always magnification is 1. So magnification is equal to 1 for a plane mirror. But in case of concave mirror, magnification is either greater than 1 or lesser than 1 or equal to 1, because when the object is at the center of curvature, magnification is 1 as the same size of the object. When the object is in between of center of curvature and focus, the image is enlarged, so magnification is greater than 1. And when object is in between from in between from center of curvature and infinity, so image is diminished, so magnification is less than 1. And when, so this is the relative position of the object and its magnification. So this is important while you solving the when you solve a different type of question, this is clear to you automatically. Now this is a question: find the position, size and the nature of image found by spherical mirror found by the following data. So we have some data: u is equal to minus 20 centimeter, f is minus 15 centimeter and h naught is 1.0 centimeter. Now here, see here, f is minus 15 centimeter. It means that the focal length is left hand of the origin. So this is a concave mirror because focal length is negative. So this is a concave mirror. So from seeing the value of focal length, that is either it may be positive or negative. If it is positive, then it is convex mirror, and if it is negative, so this is concave mirror. So f is equal to minus 15 centimeter. Here we have f is equal to 15 centimeter. Now u is 20 centimeter. So suppose this is the image distance, here u, so this is f, u is, we have 20 centimeter, okay, and h naught is equal to 1.0. So first of all we have to find the value of v. So we have mirror formula: 1 over v plus 1 over u, this is equal to 1 over f. So we can put the value with the, we can write 1 over v is equal to 1 over f minus 1 over u. So 1 over v, this is equal to 1 over f is minus 15. So this is minus 15 minus 1 over u is minus of minus 1 over 20. So here we put the value of u with its sign. So further we can write here minus 1 over 15 and this is equal to minus, here this is plus, okay. So minus minus plus 1 over 20. Now the LCM of 15 and 20 is 60. So this is 60. So we have minus 4 and this is plus 3. So minus 1 over 60. So 1 over v is equal to minus 1 over 60. So v is equal to minus 60. So image distance is minus 60. So this is, we have focal length is minus 40. So image is, so center of curvature is 30 centimeter. So image is beyond the center of curvature. So image is formed in between of center of curvature and infinity, and negative sign tell us this is inverted one, and the image is left hand side of the pole, and magnification is 1.0. So m is equal to height of object, m is equal to minus v over u. So minus v is minus 60 and u is how much? Minus 20. So minus 20. So magnification is 3 times with negative sign, that is negative sign say that the image is inverted, okay. Now height of object is 1.0 centimeters. So height of image, if we write here, height of image is 3 times of object. So 3 multiplied by 1.0. So height of image is 3 centimeter but in inverted position. So this is the position where the image is formed, the size of the image and nature of image. So we can say that nature of image is enlarged, it is formed in between center of curvature and infinity, it is inverted and real. So once you solve this type of question, you get find a lots of information about the formation of image. And please verify whenever you solve this type of question, please verify it with the solution of solution with your theory, so you get a closer look. So for this, today we end the class. In next class we will do the numerical based on these two formula, that is the mirror formula and magnification formula. So learn this formula. Hope you understand the class. Thank you very much. And lastly, if you understand the lecture and if you like this lecture, then please subscribe my channel and share this video to your friend. Thank you everyone. Have a good day.